Hey there, this is Amir Khan from IQ Academy Coaching Center, and today we will deal with Ohm's law and resistance. We have already discussed about current and potential difference in the previous sections. If you haven't seen the videos, please go back and then come back. Ohm's law. Ohm's law states that when all the physical conditions remain constant, the potential difference across the ends of a conductor is directly proportional to the current flowing through the conductor. That is, V is proportional to I. If we remove the proportionality symbol, we use the proportionality constant R. V becomes IR, where R is the resistance of the wire. If we plot a graph between V and I of an ideal conductor, we will see that the graph is a straight line, which is denoted here by the red line. This graph shows the resistance of the wire. Resistance. It is defined as the ratio of potential difference across the ends of a conductor and the current flowing through it, that is R equals V by I. Or it can also be defined as the effective opposition offered to the flow of current by a conductor. The SI unit of resistance is ohm and it is a scalar quantity. Factors on which resistance depends. The resistance of a wire may depend on many things. Three of the most prominent are nature of the material of the wire, length of the wire, and cross-sectional area of the wire. The resistance is directly proportional to the length of wire. That is, if you increase the length, resistance also increases. If you decrease the length, resistance also decreases. The resistance of the wire is inversely proportional to cross-sectional area. That means if the area is greater, resistance is less, and vice versa. If we combine the two equations, we get R proportional to L by A. Removing the proportionality symbol, we get R equals rho L by A, where rho is specific resistance or resistivity. Resistivity. Resistivity can be defined as the resistance offered by a conductor of unit length and unit cross-sectional area. If you remember, then from the previous equation, R equals rho L by A, cross multiplying things, we get rho equals R A by L. If length is 1 and area is also 1, so we have rho equals to R. Hence the definition. The SI unit of resistivity is ohm meter. Combination of resistances. Number 1. Series combination of resistances. Two or more resistances are said to be in series if they are connected end to end to one another. That is, where the first resistance ends, second one starts. It will be more clear with the diagram. In a series combination, the current remains the same across all the resistances and the potential difference gets distributed across them, as is evident from the diagram. That is, we have V equals V1 plus V2 plus V3. V equals to IR, so IR becomes IR1 plus IR2 plus IR3. Because I is constant, it will not change. Taking out I common, IR equals I into R1 plus R2 plus I3. I cancels out and we have R equals R1 plus R2 plus R3. If there are n resistances, we have R equals R1 plus R2 plus R3 plus so on to Rn. Parallel combination of resistances. Two or more resistances are said to be in parallel if they are connected between the same two points, between the same two terminals, as can be evident from this diagram. In a parallel combination, the current gets divided, whereas the potential difference remains the same. So we have I equals I1 plus I2 plus I3. Now I becomes V by R. So V by R equals V by R1 plus V by R2 plus V by R3. Taking out V common, V by R equals to V into 1 upon R1 plus 1 upon R2 plus 1 upon R3. V cancels out and we have 1 upon R equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. For n resistances, we have 1 upon R equals 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus so on to 1 upon Rn. I hope this was useful to you. In the next video, we will discuss about electric power and calculation of electric bills using electric power. So kindly make sure that you subscribe to our channel and press the bell icon so that you will be notified for all our future updates. Thank you.